we're ready to work our special angle problems with radians in reverse, just like we did the degrees in reverse. This time I'm going to give you the value of a trig function, and I want you to find out what angles this can happen at. You'll notice at the top I've put the restrictions on there that our angles have to be between 0 and 2 pi. We aren't going to name our angles as we keep going around the circle multiple times. We're also going to be looking at, in this case, where tangent would equal a negative square root of 3 over 3. I've rewritten the 3 rules it takes for doing this. We first need to determine our quadrants. So how do we figure out what quadrants this angle might fall in? Well, since we know that tangent is negative, we can determine that, oh, yep, okay, this one must be in quadrants 2 and 4. Those are the quadrants where tangent is negative. Drawing my triangles to the x-axis, I have to go, okay, now, what angle does tangent equal square root of 3 over 3 at? And you must remember that they were doing it in radians. So you're going to go find tangent, go down to square root of 3 over 3, and then over and discover that it is a pi over 6 reference angle. So we are going to be using pi over 6 here. These angles are pi over 6 in size. Now, here's the tricky part of this. Some more 5th grade math. You need to be able to name the angle that goes from 0 over to that line. When we were doing it in degrees, we did, this is 180, that would have been 30, and we said, oh, 180 minus 30, that's 150 degrees. So we do the same thing except we do it in radians. In our case, out here, this is pi radians. So I need to do pi radians minus 1/6. So, oh no, how do I do pi minus 1/6? Well, of course, we make a common denominator and go, oh, that would be 6/6 minus 1/6, which will give me an answer of 5/6. So this angle in the second quadrant is the angle 5 pi over 6. Then we do the same thing up here with the angle in the fourth quadrant. We need to know what it is clear around to there. Once again, had we been doing this in degrees, and this was a 30-degree angle, we would have called this line 360. And we would have said, oh, 360 minus 30 degrees is 330. Well, in our case, in radians, this horizontal quadrant line, instead of being 360 degrees, we call that the 2 pi line. So we're now going to do 2 pi, and we're going to subtract our 1/6 angle. And once again, we got to do a common denominator. If that's 2 pi over 1, if I put that over 6, that's going to make 12/6 minus 1/6. So my answer is 11/6. And there are my two answers. Now, if you check out the clock, you'll notice all of your answers have to be angles that appear on the clock, because all possible special angles are listed on that clock. So, there's one problem. We need to do a few more of these. So we will move on to another one here. Suppose I make this a touch more exciting, and I say to you, okay, find out for me where cosecant equals negative 2 times the square root of 3 over 3. Once again, 3 steps. Figure out what quadrants you're in. Where can cosecant be negative? In other words, where do you not see cosecant listed in the All-Star Tree class chart? And we'll discover, yep, cosecant's got to be in the bottom 2 quadrants. Then we need to know what angle, what reference angle, what special angle are we at if cosecant is 2 square root of 3 over 3. Well, okay, that's not going to be in the chart because it's a reciprocal of sine. So we have to, do you really want to have to take sine and flip it over? That's going to be pretty ugly to rationalize and simplify it. You really don't need to do that. Common sense, once again. Look down the sine column. What is the only value down that sine column that could possibly have a square root of 3 in it and a 2? Well, of course, it's got to be down here at the 60-degree line, but in our case, we're doing radians, so go over That's the same thing as pi over 3 radians. So this angle, these angles I have down here are pi over 3s. Now, this time I'm not going to write out all the fractions because I think we can do mental math. I need to know what is the angle from 0 to that first line. I know the horizontal line is pi. I need to add on 1/3 more. So I'm going to make a common denominator here. I'm going to change this into 3/3. 3/3 plus 1/3 makes an angle of 4/3. So we have one angle is 4/3 pi. Okay, the second one's a little trickier because I have to go all the way around, almost completely around. So I have to once again work from the fact that the horizontal line is 2 pi. But I need that in thirds. 2 pi over 1 is how many thirds? It's 6/3. So you're doing 6/3. We need to back up 1/3, which would give us an answer of 5/3. And so my answers to this problem are 4 pi over 3 and 5 pi over 3. Okay, I want to do one last problem because there's one other situation we have to deal with. What do I do if this thing falls on a quadrant line? So we're going to do one here that involves a quadrant line. Now, how will I know I'm doing a quadrant line? Pretty simple. If I ask myself, where does sine equal -1? Same thing I told you before. If you notice the top row where 0 degrees is located and 0 radians, you'll see all the values are 0s or 1s. On the bottom row where 90 degrees or pi over 2 is located, you have 0s, 1s, and undefined. So if you see 0s and 1s or undefined, you should go, oh, I am probably on a quadrant line. So in our case, there is no find the quadrants because it's not going to be in the quadrants. You simply need to look at the chart and go, where does sine equal 1 at? Well, we'll find the sine column, sine equals 1, clear down here at the bottom. And we don't want degrees, though. We want radians, so we want pi over 2. Now, here's the deal. It's +1 up here at pi over 2. So where is it -1 at? Of course, some of you said it's -1 down below at the bottom of the quadrant line. So then you just need to name that angle. What is that angle that goes around to that point? Well, hopefully you've just flat learned it, but if not, it is 1½ pi. 1½ is the same thing as 3/2. So yes, it makes your answer 3 pi over 2. And you have a quadrant line answer. Now hopefully you've got the general idea of what you're about here. This does take practice. If you sit there and do this worksheet, you won't have any trouble with this. If you don't do your worksheet, you're going to suffer greatly. For most people, the tricky part is the second part we did, where you have the multiple steps, because the problem with these problems is if you miss one little thing, then it messes up your whole answer, and it's really hard to tell which part was wrong. It may just be a negative sign. It may just be you forgot to do a reciprocal. So if you are stuck on these, don't hesitate to come ask me for help. Have a good day and enjoy your Tricky.